All right, equations of lines. So we have talked about the equations of lines. Now we are going to talk about writing equations of lines. And so you're going to be given information, and now we're going to write the equations of lines. We need to review a few formulas which you'll need to know. Probably won't give these to you on the chapter 12 test. The final, you'll have access to all the formulas. But for the chapter 12 test, you should know these. When you see this formula, anybody venture a guess at what this formula is? Slope, right? And then this formula is, we talked about that last week, slope intercept, right? And then there is another one, which would be y minus y1 equals m times x minus x1. That's point slope form. That can be useful for writing the equations of lines. Not necessary. I'll probably show, hey, Ms. Glendale. Yeah, you've been chosen. Okay, so then this is point slope form. When we go to use equations, you can use slope intercept or point slope. We'll see that. And then the last one is standard form, ax plus by equals c, where a, b, and c are all integers, and then x and y are on the same side, and their constants on the other. So those are all equations you should know how to use them for some of the purposes that we'll be doing for this chapter. So if you are given, we'll just jump into some examples here. If you're given some information that says write the equation in slope-intercept form. So if it says write in slope-intercept form, that means when we're done and looking for our answer, it will be y equals mx plus b. So the information they give you, we'll do some examples up here. Nice and gentle information for this first one. They give you this. They say, hey, here's your slope, here's your y-intercept. It's really nice. If you have a slope and you have a y-intercept, it would make the absolute most sense to plug into the slope-intercept form, because that entails having a slope and the b value is your y-intercept. So that's all we're going to do is we're going to plug right into here, and we would say y equals slope, so -1/2 x, and then plus 1. That's all there is to it. And then you would be done. So when they give you a slope and a y-intercept, very straightforward. You plug in the slope-intercept form. That's all there is to it. Now, they will branch out from there, and they will state something like this. They will give you a, let's say, slope of -3, and then they say an x-intercept of 6. X-intercept equal to 6. So the issue with this one is this is not a y-intercept. So you cannot just plug into slope-intercept form for m and b, because b only stands for your y-intercept. They gave you an x-intercept. So what they did is they gave you a point, even though it's not written as a point. This point that they gave you is 6, 0. So they gave you a point and they gave you a slope. So there's two routes to go. I'll show you both. You can choose which route you want. You can plug it into y equals mx plus b, or you could do it into point slope form. So we'll start with y equals mx plus b first. If you look at that, there's 4 variables listed up there. In the end, you need to fill in for m and you need to fill in for b. So far, they've given you an m, they've given you an x, they've given you a y. The one thing they haven't given you is the b. So what you can do is you just plug in and you say, okay, 0 for y is equal to mx, so -3, x is 6, and then plus b. b is unknown. So again, we plugged in 0 for y, m for -3 for m, and then 6 for x. Now we get out 0 is equal to -18 plus b, and we see that b is equal to 18. Now we found what b is, we know what m is, and all we do is just plug into y equals mx, right? So negative 3x plus 18, and we're done right there. So that's using the slope-intercept method, a nice way to go. Just find your b value and then solve for b, right? And then plug back in. That's a nice way to go. The other method is to use your point-slope form. And in this, you will plug in your point and then plug in your m. And so you would state y minus y1 is equal to m right here times x minus x1. X minus, our x value is 6. And y minus 0 is y. And then negative 3x plus 18. And we are done that way. Negative 3x plus 18. And you end up with the same answer. Now, it works really nice, this one does, when you have an x-intercept, and that value is 0 because it's just y. And so that makes it really nice. If there was a value of like 2 here, it still is fine. You can plug in the 2 there, and this would be a 2 over here. But either method works. So whichever one you want to do. Most people end up doing y equals mx plus b, this form, because that's what they memorize and they're used to it. And they don't use this one as much, but either one works fine. Okay, so what happens when you do this? We'll do an example where we can do both options here. Okay, it passes through, all right, so it's going to pass through 2 points, 6, negative 1, and negative 3, negative 7. Okay, so in this case, they gave you 2 points that it passed through. What they didn't give you is, which was really nice on number 1 and 2, they gave you the slope already. They did not give you the slope already. But can we easily find the slope with our algebraic methods and an equation? Absolutely should be able to. So what you need to write the equation of line is you need a point that it goes through and you need a direction. And the direction we describe with lines is the slope. So we have a point, we can choose either point, it doesn't matter. And now we need a slope to tell us which direction we're going. So the slope, we just find the slope of it, y2 minus y1 over x2 minus x1. I usually take this as my y2, you don't have to. You could say negative 1 minus the negative 7 and 6 minus the negative 3, it doesn't matter. So negative 7 minus the negative 1, negative 3 minus 6. And so we end up with a negative 6 over negative 9. So your slope is going to be reduced to 2/3. Okay? So now it's like they gave you a slope, just like we had right here, and they gave you a point. Doesn't matter which point I choose. The answer is no, it doesn't matter. So whichever point looks more palatable to you or easier to use, doesn't matter. So we have, there's our slope, and we're going to choose a point. So I'll just choose this point, so I have a point and I have a slope. We'll do both methods again. I'll write this mx plus b. Again, what they gave you is, they gave you an x, they gave you a y, and they gave you a m. The only thing they didn't give you is a b. And so we can easily find b by plugging in negative 1 for y, 2/3 for my slope, and then 6 for my x, and then b. 2/3, so then we just do a little bit of arithmetic, and we get 4 plus b, so b equals negative 5. And then once I have that negative 5 there, I know my b value, I know my m value, and I say y equals mx plus b. And there's my answer, just like that. Okay. If you want, I'll show the other way, which is to go y minus y1 is equal to m times x minus x1. This equation here has value later on in mathematics. We end up using this a little bit more. But if you don't want to use it for now, there's no issue whatsoever in going this route for now, at least for these ones. So we say y minus a negative 1 is equal to m, which we found out was 2/3. X minus, we said, is 6. And so y plus 1 is 2/3 x minus 4, is distributing the 2/3 in. Subtract the 1 over 2/3 x minus 5. And you should end up getting the same thing. Okay? So that's what we have there. Okay, let's do this one. Number 4 here. This says perpendicular, and this will take you back to what you know about perpendicular lines. Perpendicular to y equals negative 1/3 x minus 2, and then it passes through, okay, 1, 2. So again, with everything that we're doing here, the thing is that you need is, what do you need to write the equation along? You need a point and you need a slope. So when you're looking at something, what you're looking to identify is you're looking for the point and you're looking for the slope. Okay, so in this case, did they give you a point that it goes through? Absolutely, they gave you 1, 2. We don't see anywhere where they gave you a nice, hey, the slope is this, the slope is this. So like on this one, they gave you this, we had to get the slope. So here, we know our point, check, that's taken care of, it goes to there, we just need to find the slope. But the information they gave you to find the slope is this. They said what? Perpendicular to that. What do you know about perpendicular lines and their slopes? This is a review from 12-1. They're opposite, right? And they are reciprocal. So we go to the slope of this line, and it's negative 1/3. So what's the slope of our new line going to be? Positive 3, right? So reciprocate it and change the sign. And so now I have a slope, and now I have a point, and we just go from there. Y minus 2 is equal to 3x minus 1. Y minus 2 is equal to 3x minus 3. So y is equal to 3x minus 1. Kind of speeding through that because it's the same thing we just did over here. Same type of thing. So just plug in the values for x and y. If I just use point slope form, that's what I end up using most often. All right, so then you'll have a graph. You'll have to look, and they say you look at a line and you state the slope and the y-intercept. Guys, if you are looking, I'm not going to pull up a graph paper on here, but you know, if you're looking at a graph that looks like this, you find the y-intercept, right, just by looking and seeing where it crosses the y-axis. So they're going to say find the y-axis, y-intercept and the slope, and then write the equation of the line because they want you to what? Find the y-intercept, find the slope, and then plug it into this. Just to double check, y-intercept is pretty straightforward, just where it crosses. How do I find the slope? Now the slope will be found because they will have a bunch of grid marks on there, right? And so the slope will be found by just figuring out you go up 1 and over 3, something like that. You say, okay, up 1, a rise of 1, a run of 3, so my slope is rise over run, it would be 1/3, just by counting. Usually people are familiar with that, but sometimes they might, I don't know, they might not be. So just count the grid marks to find the slope, and then you're set there. Okay, find the equation in slope-intercept form again. So those are the same types of things going through a slope and a point. We talked about that. Okay. If something, I don't do a whole problem because I'll save you the time, but if it says parallel to something and passes through something, what do we know about parallel lines and their slopes? Those are the same, right? So in that case, you just use the same slope. So I'm not going to do another example like that. That would use the same slope. We're going to see other ones like this. Perpendicular to the y-axis. Okay, let's actually I'll do a couple ones that are a little bit unique. Okay, this says perpendicular to the y-axis, passing through 5, -6. Okay, so you're supposed to take that information and write the equation of a line. Now with this, again, you need a point and you need a slope. So this one's a little bit unique in that it says perpendicular to the y-axis. So when you think about a y-axis or an axis, right? So you have a y and you have an x. So if something is perpendicular to the y-axis, what kind of line is it going to be? Yeah, it's going to be a horizontal line. And we know, based off our discussion in 12-1, what do we know about horizontal lines? They have, well, they do have a slope, but it is 0. And then what kind of equation is it going to be? And this is where your knowledge of that, because it doesn't, some of these don't fit nice and neat into a slope-intercept form or something. We know that if you think about this, it's over 5, 1, 2, 3, 4, 5, down 6, 4, 5, 6, so over 5, down 6, right? So we know it goes through this point, 5, negative 6, and it's perpendicular to the y-axis, which means it's got to look like this. So you write the equation of a line for that. Horizontal lines, right, are y equals or x equals. That's what you have to memorize. You have to figure that out. Or you can kind of look at it and maybe be able to recognize, hopefully, what value is not changing. Is my x value changing or is my y value? Like, which one's not changing? And we look at that all the way along here, the y value doesn't change at all. Therefore, that's going to be y is equal to, what's my y value? Negative 6. And so that would be your equation, okay? And if it's something that's a vertical line, it's x equals, and whatever x value it goes through. So you'll have to pay attention to those ones. Okay, we are going to stop there, and there are lots of different problems, but they're all kind of similar to what we just did. Hopefully that will give you some examples to go off of. And I don't think, if you want more graph paper, you can grab more graph paper in the back, but I don't think you need it for this unless you really want it.
It's just,
Yeah.